Welcome to Module 1, Connected Buildings as Networked Operational Systems. In this module, we begin with a professional mindset shift. A BAS network is not just a cable plant, a switch, a VLAN, or an IT utility. It is part of the operational architecture of the building. A network failure may not directly heat or cool a space, but it can remove alarms, trends, operator graphics, remote support, historian data, and recovery evidence. So our first question is practical. What physical mission must continue, and what digital dependencies support that mission? Our learning objectives are field-focused. You will explain why the BAS network is part of the operating system of the building. You will map physical outcomes to digital dependencies. You will distinguish availability, reliability, latency, jitter, and determinism in practical language. You will define ownership across BAS, IT, cybersecurity, and operations. You will also identify the risk of uncontrolled connectivity. By the end, you should be able to build a simple service dependency and recovery map. The core concept is that a connected building is a cyber-physical operational system. The network itself does not heat, cool, ventilate, or protect equipment, but the network can decide whether those functions remain visible, manageable, secure, and recoverable. Think about a central plant graphic, a pressure alarm, a cloud analytics connection, or a vendor support session. The physical process is real. The digital path supports observation, decision-making, documentation, and recovery. That is why we design from the physical mission backward. This stack connects the physical process to the business outcome. At the bottom are HVAC, electrical systems, meters, sensors, and actuators. Above that are controllers, supervisors, gateways, and local logic. Then come Ethernet, routing, VLANs, firewalls, monitoring, servers, databases, identity, APIs, dashboards, analytics, and business reporting. The professional task is not to memorize the stack. The task is to understand the dependency chain. If any layer is unknown, the team may lose visibility, control, evidence, or recovery during a failure. The first network question is not, what switch should we buy? The first question is, what physical mission must continue? A hospital pressure control system, an office energy reporting service, a school ventilation schedule, and a central plant integration may all use Ethernet and IP, but their consequences are different. For each connected service, document the operational purpose, affected equipment, users, acceptable loss of control, acceptable loss of visibility, acceptable data loss, and required recovery time. The operational definition determines the network requirement. These terms are related, but they are not interchangeable. Availability means the service is accessible when required. Reliability means it performs without failure over a period. Latency is the response delay. Jitter is variation in the delay. Determinism means the response can be predicted within an acceptable bound. Many BAS functions tolerate normal enterprise network performance. Others do not. A low average latency can hide occasional 10-second delays. A controller count can look normal while values are stale. Always measure technical performance in physical context. OT and IT use many of the same technologies, but they often optimize different outcomes. IT commonly focuses on confidentiality, standardized platforms, rapid vulnerability response identity, and enterprise monitoring. OT focuses on safe physical behavior, predictable availability, long equipment life cycles, controlled change windows, and local recovery. Neither priority set is complete by itself. The responsible model is joint governance. IT brings network, identity, platform, and security expertise. BAS and operations bring process consequence, functional testing, equipment lifecycle, and recovery knowledge. Every important service should have an owner and a dependency map. A BAS application may depend on virtual hosts, storage, databases, DNS, NTP, certificates, directory services, firewall rules, remote access services, licensing, backup infrastructure, and physical power and cooling. Undefined ownership is a technical vulnerability. During an incident, delayed decisions and incomplete records can create longer outages than failed hardware. A useful dependency map answers 5 questions. What service is required? What does it depend on? What depends on it? Who owns each layer? And what is the tested recovery path? Here is a realistic field example. A campus historian stops receiving data after a network change. The BAS servers are online. Field control continues. Users can open graphics. The first assumption is a historian software problem, but the dependency map shows that the collector resolves the historian by DNS name across a routed boundary. The firewall allows the historian data port, but it blocks the approved DNS resolver from the OT collector VLAN. Direct IP succeeds, name resolution fails. The correction is to restore controlled DNS access, document the dependency, and add a name resolution health check. Use a repeatable diagnostic method before changing rules or rebooting systems. First, define the physical mission. What operation is affected? Second, identify the service boundary. Are we testing the server, the database, the graphic, the historian, or the alarm service? Third, map dependencies. Then test the path and the return path. After that, verify the actual application service. Finally, confirm recovery. A successful ping does not prove alarms, trends, commands, data quality, operator workflow, or restoration. Use this checklist before accepting a connected BAS service as ready. Document the physical mission and affected equipment. Define acceptable loss of control, visibility, data, and remote access. Identify which functions remain local when higher layers fail. Map application, network, identity, time, certificate, and platform dependencies. Assign owners and escalation contacts. Define measurable service objectives. Then test at least one representative failure and recovery path. Remember, connection is not integration, and integration is not resilience. Let us summarize Module 1. ABAS network is part of the operational system. Local control is important, but it does not eliminate the operational value of supervisory systems, alarms, histories, reports, and remote support. Availability, reliability, latency, and determinism must be defined in context. OT and IT must share accountability. Dependency maps reduce outage time and improve decisions. In Module 2, we move to Ethernet and physical network infrastructure, where we prove the signal, link, frame, and switch path before blaming the protocol. Before moving on, pause and test your understanding. Why is a BAS network part of the operational system? How do availability and determinism differ? Which BAS functions should remain local during a server outage? What hidden dependencies commonly affect BAS applications? And how should OT and IT share accountability? For the field prompt, choose one BAS service and sketch its physical mission digital dependencies, owner, and recovery path.